So today we're going to continue with our discussion of chemical foundations and talk about isotopes. Okay, well, we just finished talking about the history of the atom and all the different models, and we determined that all atoms contain protons, neutrons, and electrons. So if all atoms have the same parts, then why do we have different atoms with different chemical properties if they all have the same three things? Okay, and the answer to that is based on the electrons. The number and the arrangement of electrons will determine an atom's chemical properties, and the main reason for that is because electrons are on the outside of the atom. They're going to be the part that intermingle when atoms combine to form molecules, and so they are going to determine bonding, and we'll talk a lot more about that later. So what this means is that we have to make a change to Dalton's theory then, because his theory said that all atoms of a given element are identical. But we know these electrons aid in bonding, and we also have a part of the atom that can be different. James Chadwick discovered that the nuclei of atoms contain neutrons and protons, which we talked about already. And the change in Dalton's theory comes from the neutrons. All atoms of the same element have the same number of protons, and for now we're going to say the same number of electrons. This will change as we get into ions. But the number of protons identifies an element. So for example, if you have an atom with 11 protons, that always has to be sodium, and that's due to the atomic number, and we'll talk about that. But protons identify the element. What can change and still have the same element is the number of neutrons. And so that's what we're going to talk about when we talk about isotopes. So an isotope is an atom that has the same number of protons as other atoms, but it's got a different number of neutrons. And so we can have several different isotopes for certain elements. So for example, the sodium atom has 11 protons, and this comes from the fact that its atomic number is 11, and that identifies the number of protons. Because right now we're going to assume the atoms are neutral, this means they must also have 11 electrons. So in general, number of protons and electrons for an atom is going to be the same. So we know that each sodium atom also has to have neutrons, and different types of sodium atoms exist that have different numbers of neutrons, and those are called isotopes. Okay, so here are some examples. So there are three main isotopes of carbon. Carbon-12 and carbon-13 are stable. Carbon-14 doesn't exist very often because it's unstable. So if we take a look, the yellow or the orange ones are electrons. So we have 1, 2, 3, 4, 5, looks like 6 electrons, and they all have the same number of electrons. Let's take a look at the protons. Protons are blue. 1, 2, 3, 4, 5, 6. We've got 6 protons. Now, because the number of protons identifies the element, all of these atoms of carbon should have 6 protons. 1, 2, 3, 4, 5, 6. And if we count this one up, we also have 6 protons. Okay, now let's look at the number of neutrons. Neutrons are red. First of all, we have 1, 2, 3, 4, 5, 6. So 6 neutrons for that one. If we count out the second one, we have 1, 2, 3, 4, 5, 6, 7. And if we count up our third one, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our numbers of neutrons are different, and that's why these are isotopes. Now you may be wondering where this 12, 13, and 14 come from. We'll talk about this in a minute, but if you add up the number of protons and neutrons, you should get 12 for the first one, 13 for the second one, and 14 for the third one. Okay, a couple more examples. Here the protons are red, neutrons are green. You can see we have 3 isotopes of hydrogen, same number of protons, different number of neutrons. Same is true for these 2 isotopes of helium, and the same is true for these 2 isotopes of lithium. So same number of protons to identify the particular element, but different number of neutrons. Okay, so we've been talking about atomic numbers, so let's talk about a few terms. The atomic number is the number of protons in the nucleus. It identifies the element. If you change the number of protons, you change the identity of the element. It's really important. The other key piece of information is the mass number. The mass number is the sum of neutrons and protons in the nucleus. And so since we know the number of protons from the atomic number, and if we know the mass number, we can find the number of neutrons. Atomic number and mass number are both found on the periodic table. Okay, so if we look at this symbol, this is the way that atoms are written a lot of times. X represents the element symbol. And so for sodium, we could have Na. A represents the mass number, so that's the number of protons and neutrons. In general, and we'll talk about where to find this on the periodic table, it's about 22. And then Z represents the atomic number, that's the number of protons. And we know for sodium, the number of protons is 11. Okay, so this is how we would use this symbol to write for sodium. So let's look at an example. Oh, okay, in this case, it's the mass number is 23 instead of 22. So 2311 Na is called sodium 23 because its mass number is 23. Remember, that goes on top. So if we want to find the number of protons, well, that's equal to the atomic number, which in this case is 11. Okay, if we want to find the number of electrons, we know that in a neutral atom, the number of protons is equal to the number of electrons, and so they're both 11. And if we wanted to find the number of neutrons, we know that the mass number is protons plus neutrons. And so if we take the mass number minus the number of protons, which could also be called the atomic number, that will give us the number of neutrons. And so 23 minus 11 gives us 12 in this case. Alright, let's try a couple more. Determine the number of each of the three types of subatomic particles for each of the following. Okay, so cobalt has a mass number of 60 and an atomic number of 27. We know atomic number equals the number of protons and also equals the number of electrons, and we know that that's 27. So now all we have to find is the number of neutrons. Well, the number of neutrons is equal to the mass number minus the atomic number, and in this case it's 60 minus 27, and so that gives us 33 neutrons. Yeah, let's try another one. Alright, so here is the symbol for chlorine. So we know that the atomic number is equal to the number of protons, which also equals the number of electrons, and we know that the bottom one is the atomic number, and so that's 17. For the number of neutrons, we know that equals the mass number minus the atomic number, and that's equal to 37 minus 17, so that gives us 20 neutrons. And the last one is for uranium. Okay, we know that atomic number is equal to protons, which is also equal to electrons, and that's our bottom number, so we have 92 protons and electrons. And then to find our neutrons, it's our mass number, which in this case is 238, minus our atomic number, which is 92, and when you subtract those, you get 146 neutrons. Okay, now all of this information is available on the periodic table. For each element, you usually find the symbol, and then definitely the atomic number. Now, the other number that you'll find is what's called the atomic mass. Oops. This is an average of all the mass numbers for all the isotopes for a particular element. So, for example, if you remember from our carbon example, carbon-12 and carbon-13 were very stable. Carbon-14 was not. And so if we took an average of the mass numbers and how often they exist in nature, carbon-13 and carbon-14 aren't very common. They don't exist a whole lot. And so our atomic mass for carbon ends up being 12.01. So what this means is that carbon-12 is very common, but we have a few carbon-13s and a few carbon-14s that are affecting the average. And so usually what we do to get mass number is just round the atomic mass to the nearest whole number. So in this case it would just be 12, and that would be our mass number. Now for something like sodium, which I believe is 22.99, if we were to round that, that would round up to 23. And so just use your regular rounding rules to go from atomic mass to mass number.